How's it going, everyone? Welcome. Julian Gonzalez here, and I want to make a quick recap of how do we get here, especially by building our own HTTP server in Node.js. But first is I just want to show you is real quick. Here is this. So what I did in the past video is just to explain now briefly how now the HTTP comes to fruition by digging into the root of where this technology comes from and what this technology is built on top of what, right? So there are several things that are involved in order to understand this. So one of them is the computer architecture. So it is important to understand the anatomy of this computer, at least at the hardware level. So the CPU, the memory, the input and output, the storage like the disk, and an additional hardware that has been added as part of the need in making this technology useful for ourselves. So one of them is for input and output like camera or mouse or keyboards, and also for network cards, in other words, so applications or programs that live in these computers and then you somehow wants to communicate to others somehow, right? So that somehow is known as the socket, which is an interface that allows you to now different programs to communicate, whether it's locally, known as the IPC, or with another computer or with another process or program that live in another computer through the TCP sockets, right? And here, because there are several sockets, right? The most relevant here, at least for HTTP, is those that are for the way of communicating with other programs. So, again, it's important to understand the component, the computer architecture, as well as what you can run on top of that, which is the OS, which ultimately is the one that allows us to now run our applications. And in this case, as you can see here, an stateless application level protocol for distributed collaborative hypertext information system. So there's a lot of jargon here, right? But the thing here is that if you want to run this, you need to run, it will run at the application level. This application is now what you can use in order to execute a program using now the operating system, which is a software that is going to act as the manager, as the resource manager. So in terms of CPU, the memory, the network stack, as well as other things that the OS allows you to do. So for example, in terms of security. But what I really care about that is once you understand now the anatomy of your OS, and this can be split at least commercially into main branches, the Unix base, which is what I'm actually quite familiar with and what we are going to look in today's video, and what is being now heavily used a lot across different service providers, hostings or server providers. So they're using now this branch of Unix known as Linux. And then you have now the MS-DOS, or commonly known as Windows. So, because you have now these two different systems that in the context of understanding how now these applications runs, aka what it's a process, and it's just to answer this simple question is that how do the system operating Jesus, the operating system knows that this is a program that is being executed, right? And this is because when you now tell the OS to run this particular program or to execute this program, which is now a program that was already previously compiled in C or any other compiled language, usually compiled language like C or C++, that will generate now after the compilers see and say, hey, everything is good, right? Now the compiler, what it's going to do is to generate now is an object, or in other words, is going to generate now is an output, and this output is what is going to be used by another program, which is the compiler, to verify that your code works as expected. There is no syntax errors, and then it's going to now rely on the system call that there are services that are provided by the OS that allow that compiler to run the code. This is not true for certain applications, but in any case, the compiler, that's what it does. It takes now a program, a source code as an input, and then it's going to generate now is a portable binary executable code. The interesting is of how now a compiler works. I go well beyond the scope of today's video. What I can say is that think of it as like a process or like an assembly line where it's going to accept a source code, and it's going to pass through different steps in the assembly line or in the compiler factory that is going to transform that into something that the computer can understand, which is the zeros and one. This process may vary, but usually in the classic compiler theory, you have now the phase of lexicon or tokenization, all right? And this is the phase of it's going to now take your source code and see if you actually use the text and create now something called as the abstract syntax tree if everything went well, which is an internal representation of what these programs look like by the computer. And then it's going to now is generate the code for that specific architecture or the OS, right? The architecture and the OS. So that output is what you're going to use and tell the OS to say, hey, now this is something that you can understand unless you're going to execute that. So again, there's several layers on top of that, but again, I do want to focus is on the HTTP and the process. So why I describe that process of the compiler, because once you now tell the OS to create a process, which is the way of how you can actually run an application like this, in this case an HTTP server, right? What you want is to know how that things happens. Again, let's go well beyond the scope of today's video in terms of the operating system and how now the operating systems create this process or answer the question of how now a program, a set of instructions are going to be understood and executed by the underlying hardware, right? So the TLDR is that when you want to run an application, the OS, as a way to keep track of this program, is going to now create this page layout, which is a way to say, hey, let me now reserve a space in memory for this process. and this is the organization. So this is the structure of how this page or this space in memory is going to be split logically. So you have at the bottom sections like the text source code, and then some space for local variables and shared variables. Then you have now the heap that is going to increment from bottom to top, right? Then you have is the stack that is going to increment is from top to bottom. The difference between the heap and the stack is that on the heap you can store now objects, and on the stack it allows you to now these function calls, right? And then on top of that you have now some of this, at least in the Linux kernel, you have now some space in memory reserved for kernel system call. So this is now the organization of this process in memory, right? And what it's going to do is to now call the CPU to execute this statement in this program, right? So remember that since this is the page layout and this is all of this live is on the memory, and the memory, the only thing that it knows is zeros and one, thanks to the transistors that actually are very it act like a switch, all right? That they say, hey, I can hold this amount of voltage, or I can freeze that, right? I can say this is zero, so there is no voltage here, and because this is the only thing that is on the memory, right? So all of this sequence of voltage or zeros and ones, right, are going to be passed over to the CPU in a particular sequence or length, size length. Some computers use now 32 bits to represent that. Others use an extensive bit sequence like 64, would allow you to represent more and more piece of information. So the CPU has its own registers that you have general purpose register or the program counter that indicates that, hey, this is a specific section of this is the specific line that we are evaluating, or this is the next line that we need to evaluate. It also have another register that is handling is the current statement, right? That is evaluated, and this is now what a process is. So the OS can create many processes as you need it, right? And all of them now live in their own particular memory in a space. If you want to somehow need to create this thing called threads, which are unit of execution, these units of executions allow you to now, since they're going to live as part of the page layout, right, or the virtual memory address, right? Since they live now inside of the page layout on the process, they allow you to now run specific tasks concurrently, and if your architecture support multiple threads, but it's a multiprocessor, then it can now take advantage of the multiple CPUs that it has, physical or logical CPU. So this is the thing of the difference between the process and the thread, right? So the thread, at the end of the day, have access to all of this registers, records, the program, and share the memory, right? So this is one of the main differences between the process and threads. And you may wonder, why do I even care about this, right? Because as you're starting to now have this HTTP server or this applications that you want us to now use for sharing documents over different computers, as long as they're using now this particular way to send message, which is the TCP, as long as they're using now the transport protocol, the TCP IP. So you want to share as many documents as possible, right, across different computers that can be used for other different people. So in the context of HTTP, right, and now move forward to what I really care in today's video, is that HTTP, which was developed by Tim Berners-Lee at CERN, the Committee European pour la Recherche Nucléaire, or the Committee for the Nuclear Research, that he has now a computer, or at least the CERN has now a computer. It also has this way to transmit data over different computers, known as the TCP and IP. And the TCP is a way of is a way to answer this question. How can we guarantee that when we're sharing data, we do that with high quality and high confidence that is going to be sent, right? So it's more like a verification protocol, or a transmission control protocol. And then you have now the IP, which say, okay, so now that you know how to, you define, it's a protocol in which we can make sure that this piece of information are gonna be sent and there is no errors, so you can to guarantee the quality of this piece of data. Now we need to answer another question. How do we send this piece of information, right? And this is all about the IP or the Internet Protocol. The only thing that it handles is how do you now send data across all of these different computers by routing that data, right? And this is the technology that they use, right? And Tim Berners-Lee say, let me use now is this computer, this URL, this computer, this way of transmitting informations in a particular format to identify as a resource on this internet, on this network called the URI, or the URL, right? The Uniform Resource Locator, that anytime that you want to have access to a particular file that live on one computer, you can have access to. And this is the whole idea of the HTTP, right? So, because in the previous video, I look at how to do that with the HTTP 0.9, right? And this documents that you want to share is known as the, that's what the reason of H in the HTTP. So this document that you want to send are a hypertext document. And they call it that, which is a fancy way to say, wouldn't it be nice to have a document that you can, think of it like newspaper. Most of it, we barely see that, right? But back in the 90s, right? When you have now newspaper, they say, hey, wouldn't it be nice to have a document that not only that you can read text or watch image, but also to play video, to look at some illustrations, to render something on top of that. So some data illustrations, like, or you have now a canvas to paint stuff on that, and also to fill forms and submit those forms. The ability to have now tabular data. And this is now the core and the HTML, the core of the HTML living standard. So with that, right, this is what now I did in the previous video, all right, to create now an HTTP 1 service. And right now I'm reading is this RFC request for comments, which is a format of how they submit comment or proposals to the Internet Task Force 9110. And here I just want is to read about the history and the evolution. So this first section here, HTTP has been the primary information transfer protocol for the World Wide Web since its introductions in 1990. It begins as a trivial mechanism for low latency requests with simple method get to request transfer of a presumed hypertext document identified by a given path map. So when I look at this, so there are a couple things that I implemented, and I want to show you that real quick. So here we are. I think it's this one. Let me see if this. Oops. Nope. No, really? Really? Okay. Okay, no problem. There you go. There, this. Okay, so here, because I'm using now Node, which is an abstraction, it's just bindings that allow us is to create HTTP servers by leveraging something called the libuv, which is a way of how you can now is handle thousands of incoming requests without blocking the main threads in this pattern known as the observer design pattern, right? So anytime that something happens, so you can think of this pattern as part of the design patterns in software. When you say, hey, anytime that I need to is receive notification from something that I find out important, for example, is a celebrity in a particular field, biology, neurosurgery, economy, veterinary, I think that's the proper name, veterinarians. Okay. People who cares about animals, dogs, and your pet. So once you have that, right? You now you want to see now how these things turns out. I think I lose my mind here because I want to explain is something here, but in any case, the thing that I do the thing that I do want to access or want to mention is that this is no bindings, all right? The Node.js and the design system that allows to work with, okay, which is the event, the observer design pattern. So these particular patterns state like that. It answered that question. Hey, sometimes I need to receive some updates from something, and in this case can be a subject, all right? And well, how can I get now some notification when something happened? So I am an observer of this subject here. So why this is important? Because when you started to create your HTTP 0.9 version, here where the red line is now this particular model of the net. And the net is an API that is exposed to the JavaScript land by the Node.js binding, which is C++ code, that internally have access to the network stack in the OS. Whether it's the Windows or Unix base, which is Mac or Linux, right? You can have access to those directives here as part of an API or a library. And when you create now a server, at least here, you can create now is an application that is an IPC or a TCP server. What in the French toast is that? That's a good question. Let me actually look at that here, because I do find this is very important in order to fill the gap in our understanding and when you need to describe this to somebody else. So the Node.net model provides an asynchronous network API for creating stream-based TCP and IP server. There's a lot of things to unpack. Let me do that for you. So this asynchronous network API it means that it works concurrently, it doesn't block the main thread, and asynchronous is any task that will happen at some point in the future, not right now. So for example, networks requests or incoming message that we can receive, and it say that for creating an stream-based TCP or IPC servers. So you can create now is with this when you run now a node, you can create now an IPC server, right, which allows you to now start to receive incoming message from other processes. And you can see here more about that, the IPC support. And this is quite interesting because now this is something that is fairly new. You know, this is something that is fairly new, version 20. Right now we're in the version 26, right? So the Node.net model supports IPC with name pipes on Windows and Unix domain sockets on other operating systems. The idea to explain now sockets and pipes, all right, which are now ways of how this specific OS handles sharing message. Again, they just want to ask this particular question: how do I communicate from one process to another? There are several ways to do that, but one of them is using now pipes or sockets. And in the context of Unix, so now sockets, as I mentioned before, allow you to now share data across process locally, and don't take my word for granted. This is also something that comes from this guideline. Let me show you the context. The Beej's guy, all right, Brian Beej Jorgensen, all right. He is a Swedish software engineer, something like that. I think it is. Oh, is he? Brian Beej Jorgensen Hell. Okay. That's interesting. I'm assuming that is him, or, well, you know. Anyway, I don't want to assume anything here, but what I do want to show real quick is this one, Jorgensen's Labs. He is now in Oregon, Bend, Oregon, right? And he is quite active in his GitHub, as you can see. So this is it, right? You can take a look at the LinkedIn, right? Brian Beej Jorgensen Hall, right? It's a computer science instructor, an author and developer that lives in Oregon as it is, right? So now he's currently at the computer science instructor. He's also part of the Labs LLC, head of laboratory, and my personal LLC offering general software contracting and instructions, as it is. And director of computer science here, and also a CTO for this particular computer, as you can see. So that's good for him, right? So Brian Beej Jorgensen, software engineering that lives in Oregon, and he's the author of several of these books uh, to to tell the people is like, hey, please don't ever ask me this question again. For example, Beej guides like, hey, networking programming. You can also take a look at their guide to C tutorial, C++, the two network concepts, and also is for Git. All right. A Beej guide to Unix interprocess communication. But what I really care about is to this, which is to networking programming, where when I explore more about this is the socket as is, right? A way to speak to other programs using Unix file descriptors. So it goes way too deep into this, which, just to summarize and to make this life pretty simple, is to say, hey, file descriptors is just an integer associated with an open file. And here's a catch. In Unix, Mac or Linux, everything is a file. So you have now first in, first out, you have a network connection, you have a pipe, you have a terminal, a real on the disk file. So anything is now a file. And this file description is now a table that say, hey, this is this is where I keep track of the open files that I have here in this program, right? So because it relies now, as you can see here, but hey, this, you might be exclaiming right about now, it is a file descriptor. Why in the name of Neptune can I just use a normal read or write? Calls to communicate through the socket. The short answer is you can. The longer answer is you can, but send and receive offer much great control over data transmission, right? So give me a second, I'll be right back. All right. So why do I even care about this? Because at the end of the day, socket now is an API that's in the context of Unix allow is to send message from one program to another. And these programs can live locally, and for that you use now is a specific way to send a message that it is provided to you by the OS, all right? And this is known as the IPC, or inter-process communication. But if you want to now send data to other processes that live in other computers, now that's when you rely is on this internet socket. So how about this? There are all kind of sockets. There are DARPA internet address, path name on a local node, like Unix sockets, right? CCITT X25, which is X25 socket that you can safely ignore, and probably many other depending on which Unix flavor you run. But at least he mentioned mention is this too, the DARPA internet address and the path name on a local node, which is the Unix sockets. So two type of internet sockets, right? I think that might be quite boring at this point to read about this. To make it interesting and the TLDR of this is that, let me actually read about this and give you now is the condensed sections of that, because again it's quite interesting, and you feel the gap in your understanding of why, for example, when you create now a server using the net or using the net API, right? What does it mean with the TCP or IP servers? And also the stream base, which is something that I'm going to describe as well. So this is a two type of internet socket, right? So there are two type of internet socket. Yes? Well, no, I'm lying. There are more, but I didn't want you to scare. I'm going to talk about two types here, except for this sentence. Well, I'm going to tell you that raw sockets are also very powerful, and you should look at them, right? All right, already, what are the two types? One is the stream sockets, okay? The other is datagram sockets. This is what it's called, is stream and datagram socket. So which may hereafter be referenced to as socket stream or socket diagram, respectively. Datagram sockets are sometimes called connectionless sockets, the diagram. Though they can be connected if you really want, and see the connect below, which is part of the exploration of the particularly library that is exposed by the socket here, as you can see. This is now looking at the low level code, or at least in C, C sharp, C++, sorry, so you can get an idea of what this is being exposed to you. So that's good, that's good. So stream sockets are a reliable way to two-way connected communication stream. If you output two items into the socket in order 1 and 2, they will arrive in order 1, 2 at the opposite side. And this is important. This is a very important characteristic of this stream socket, a part of the internet socket, the way how you can communicate across different programs, one program to another. They will also be error-free, and I am so certain, in fact, that they will be error-free, that I'm just going to put my fingers in my ears and chant la 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 if anyone tries to claim otherwise. What uses stream sockets? Well, you might have heard of the Telnet and the SSH applications. Yes, they use a stream socket, right? So they are connections, they are two-way connected communication streams. All the characters you type need to arrive in the same order. You type them, right? Also, web browsers use the hypertext transfer protocol, which use stream sockets to get page. Indeed, if you telnet a website or port 80 and type get, right? Hit return twice, it'll dump you the HTML back at you. Holy moly. Those are applications level, or those are applications, right, that they use now stream sockets. So Telnet and SSH, it use now this a two-way reliable order connecting base communication stream. You don't have to telnet install, and you don't want to install it. On your telnet is being picky about connection to clients. Okay, anyway, so how do a stream socket achieve this high level of transmission quality? This is a very interesting. So they use a protocol called the Transmission Control Protocols, otherwise known as the TCP. You can read about that for extremely detail into the TCP. And the TCP makes sure your data arrives sequentially and error-free. You may have heard the TCP before as the better half of the TCP IP, where the IP stands for Internet Protocol. And IP deals primarily with internet routing, and it is not generally responsible for data integrity. So TCP is responsible for data integrity, or to answer that question, and the IP is for routing this message or this data. Cool. What about datagrams? Well, they are called connections, right? So what's the deal here is that they are now sent as they arrive. So they might arrive out of order, and the data within the package will be error-free. So datagram sockets also use IP for routing, but they don't use TCP. They use is the user datagram protocol. Why are they connectionless? Well, basically it is because you don't have to maintain an open connection as you do with stream sockets. And this is great. For example, you just build a package, slap an IP header on it with destination information, and send it out. No connection needed. They're generally used used either when a TCP stack is unavailable, or when few drop package here and there don't mean the end of the universe. Same application, TFTP, Trivial File Transfer Protocol, a little brother of the TCP, and the other is the DHCP-CD, which is the DHCP client. Multiplayer games, streaming audios, video conferencing, etc. Wait a minute. TFTP and DHCP are used to transfer binary applications from one host to another. Data can be lost if you expect the application to work when it arrives. What kind of dark magic is this? Well, my human friend, TFTP and similar protocol have their own protocol on top of the UDP. For example, okay, the TFTP protocol says that each packet that gets sent, the recipient has to send back a package that say, I got it, an acknowledged package. If the sender on the original package gets no reply in, say, 5 seconds, he will retransmit the package until he finally gets the acknowledgement. For unreliable applications like games, audio, or video, you just ignore the drop package, or perhaps try to cleverly compensate for them. Right? Why would you use an unreliable for speed, and speed, right? This is the reason why we use now speed. And speaking of this, it has now a low level and network theory on top of that, which is based on the OC model here. Hey kids, it is time to learn about data encapsulation. This is a very important, very important, and it is so important that you might just learn about it if you take the network course here at Chico State. Basically, it says that a package is born, the package is wrapped, encapsulated in a header, and rarely a footer by the first protocol, say the TFTP protocol. And then the whole thing, right, the TFTP header including, is encapsulated again by the next protocol, say UDP. And then that whole thing is now encapsulated, and then the whole thing, right, is encapsulated and adding a header for the IP layer, and then again by the final protocol on the hardware physical layer, say the Ethernet. When another computer receives the package, the hardware strips the Ethernet headers, the kernel strips the IP and UDP headers, and the program strips the TFTP headers. If you apply this now, for example, in the HTTP, which is a stream-based socket, or it relies on a stream-based socket, or the SSH or the telnet. So now you understand what this thing is doing here. So now I can finally talk about the infamous layered network model, or aka ISO or OC model. The network model describes a system of networks functionalities that has many advantages over other models. For instance, you can write socket programs that are exactly the same without caring how the data is physically transmitted. Serial, thin Ethernet, IUE, whatever, because programs on lower levels deal with it for you. The actual network hardware and the topology is transparent to the socket programmer, but it is important to understand that. Without any further ado, I'll present the layer on the full blown mode. Remember this for network class exam, right? You have now the application, the presentation, the season, and again, each one of those layers, they are going to now encapsulate that data and add a header that the next layer will be used that package, wrap it, adding a header, sometimes it adds a footer, and then pass that down to the next layer, the transport layer, and then the network layer, the data link, and ultimately the physical one. So that's a very, very important in order to understand this and describe the OC model, as you can see here. So the physical layer is the hardware, the serial, the Ethernet, something that we as software developers, we barely know how that things work. But again, it's up to that level that it has a series of instructions of how all of these zeros and ones are going to be sent, and are going to be sent over here. The application layer is just about as far from the physical layer as you can imagine. It is a place where the user interact with the network. Now this model is so general you could probably use it as an automobile repair guide if you really want to. And that's very interesting. Hey, sometimes when you have now a network problem, you can say, hey, if this is an application level, or if this is a transport, okay? If this is an application level problem, a telnet, FTP, right? Or if this is a host-to-host transport layer, hey, it's because the data that is being sent over somehow is not reaching its destination as it should be. Or perhaps there's some package that has been lost in the routes here, all right, internet layer. Or perhaps you are not physically connected to that device. Very, very interesting. At this point in time, you can probably see how this layer corresponds to the encapsulation of the original data. See how much work this is building a simple package. See how much work this is building a simple package? Geez, and you have to type in the package header yourself using cat. No, just kidding. All you have to do for a stream socket is to send the data out. All you have to do for datagram socket is encapsulate the package in a method of your choosing and to send it out. The kernel builds a transport layer and internet layer on you, and the hardware does the network access layer. Modern technology. So ends up our brief foray into network theory. Oh yes, I forgot to tell you everything I want to say about routing. Nothing. That's right. I'm not going to talk about it all. The routing strip the package to the IP header, consult its routing table, blah, 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 blah. Check out the IP RFC if you really, really care. If you never learn about it, well, you will live. So, in the next section, I'm going to finally close the gap here to say, all right, how do I build is this HTTP 0.9 server? Why are we using now the net interface to build that? And as you build the net or you create the server, right? Why is that you receive now is this things called socket? And what this socket is representing and how you can now implement is this basic stuff that the HTTP protocol is describing here, right? Single method get to transfer a presumed hypertext document identified by giving path name. So I'll be right back. Please stay tuned. All right, finally we are back. So the point here is I want to make now this specific overview of the history and evolution because I described early in the first segment of this video more about the things that you need to know at least at a high level overview, right? Which is you need to understand the computer architecture, how now is the motherboard organized, at least the main different components. So the CPU, the RAM, and the input and outputs, like where you can connect your mouse, your keyboard, and also USB mass storage, and the network card. Perhaps you might, in newer architectures, you can find now the NIC, the network interface card, combined with the wireless. Okay, so this is just to describe is the the architecture, right? The motherboard, and how now all of this as well as are connected. So there is another slots like the GPU and the bus that actually makes all of this piece of information flow from one place to another that can be processed by the CPU. And then on top of that, you're gonna have these things called the software or the operating systems that whatever the the design that is using behind the scenes, whether it is Unix based Mac or Linux or Windows with MS-DOS, both of them, the OS at the end of the day is just like the manager, the research manager. So they're gonna provide you now is a set of APIs or interface that you can plug in to do a specific behaviors, right? So because this particular topic is something that there are books out there like Tannenbaum that describe more about that, and for an overall overview of the operating system, what that thing does. So my expertise is more like in the Unix based systems, right? So even though, right, so this operating system is what allows to, as developer, write programs that it resembles like a language or a human language. This was not always the truth because it was initially created. This assembly line or programs were creating is in assembly language, where you have to move one record to one another place. So now the CPU can actually, based on a specific operation that you want to run, an arithmetic operation or basic arithmetic, adding, subtracting, multiply, or divide, or some logic operations. And the most common one is like AND or XOR, among others, right? Or some bitwise operators, right? You want to flip now all in a sequence of bytes. If you want to turn all of the sequence of bits into 1 or into 0, for example. So the thing here is that because at the end of the day, HTTP here is an application, it's a stateless application level protocol. What all that means is that you have to now tell the OS to run this application, and when you tell that, now the OS behind the scene is going to create now this process. So, and the process is just how now the OS can keep track of what a program is run, and it's going to encapsulate that into memory, known as the virtual memory address or the page layout, because it encapsulates that. This distribution or this configuration is made of at the bottom you have now is the program code, and then on top of that some directions in memory that represent is, well, here we're going to put is the local variables, among data, and other different things that you might see relevance. And then on top of that, there is a particular address in memory and a segment that will be specific to store objects. And the other, which starts from bottom to up. And near to the end of the address, or if you imagine this page layout like this from top to bottom, at the top of this address, actually not that close to the bottom to the top, but fairly close, you have now this thing called the stack, which allows you to now keep track is a function call. And then on top of that you have now is the at least in Unix, the operating the the functions reserved for system call, right? So this is now the page layout. And I am not sure if I can show you that because that's might be go against that, but I don't think. Let me hit the pause real quick, and I show you that. So as you can see here, this is a content from the CS 639 Advanced Programming in the Unix Environment. There's a very interesting way of how Steven, the creator of this course, actually went through this. And the idea is that when you look at this layout, this configuration, it's all about to say, hey, this is now how in memory we organize our programs to fit from this position and this another one, low address and high address. So the lower address are the text segments, initialized data, uninitialized data, and then you have now a heap and a stack that the heap is going to grow until the highest address and the stack in the lower address direction. And the heap is where you can put things like, as I mentioned before, objects, right? And the stack is what allows you to keep track of the function called stack. And on top of that, you're going to have now commands that are particularly to the kernel to say, hey, what are the things that you need to do with this program? So here we have an example of a program here of what this doing, because at the end of the day, it's all about moving one record to another. And I will leave you now the YouTube video, so you can take a look at that here. But I mentioned that because at the end of the day, when you are creating now an HTTP server, you have to create now a process. And especially if you're using now Node, this process that you are creating here, when you have access to the net interface, like a library that allows you to interact in this particular context to create HTTP stream-based HTTP or stream-based TCP server and IPC. So what is the IPC? Something that I already mentioned before, right? Servers, and here we're gonna create now our TCP. So finally, to what I really care on that section, which is creating our HTTP O1 or O9. If you remember, let me actually make this fairly quick, much more easy to read. No, much more easy to read, right? This is now an excerpt from that. So in the paragraph 1, you say, hey, HTTP has been the primary information transfer protocol for the World Wide Web since its introduction in 1990, and it became a trivial mechanism for low latency requests with a single method GET to transfer of a presumed hypertext document identified by a path name. And this is now based on that, on the history and the evolution, which is what we did here, right? So single method GET, you could only fetch things and presume hypertext documents. So everything here now is an HTML document. So there were no things like PNG or there was no way to identify any other file that is not a document. And you identify that resource with a path. And it is low latency because its leveraging is the TCP connection. So what I did here, and I also received, I must admit that I received some assistance of Claude, is to say, hey, in my particular case, I do want to create now is this thing called TCP server, stream-based TCP server, that because I do want us to now serve this content as a stream, and I'm using is the path as a way to identify this resource, okay? And also the document error page when you don't find anything, right? So in the context of Node, you can create now this TCP server using is the Node.net library create server function. And this create server function, what it's going to do behind the scene is to say, hey, anytime that the TCP server is detecting an incoming request, you might wonder who is going to detect that request for me, right? But anytime that an incoming message is being detected here in this socket, I'm gonna now to give it to you these objects, which again, socket, as I mentioned before, it represents now is, well, this communication in Unix-based systems. And it's also universally used as well for the MS-DOS, or Windows, where they use is now pipe, all right? But the deal is that this is now an abstraction, an interface, where I can now interact when I need to send message from one program to another. And that's the whole point of this. So this is about socket. And because in the context of Node, since it's using is this event pattern as a way to leverage is the DOM event model, which has been very powerful from the browser to say, hey, anytime that an incoming request is detected, or anytime that something happens, okay, an event happened, this is the interface that you're going to implement. This is the class, the event emitter class that you're going to implement. So don't take my word for granted, because if we go back here real quick to the docs, all right, and particularly when you want to create now is a server with the net create server, right? It's a now I'm gonna give to you is this thing called connection, right? The connection listener, right? And these connections or socket, right? That I call or the socket, right? That I call in this example like this, okay? It's a when the other end of the signal, the end of a okay. So just to briefly describe what is this here, right? You can pass now a couple options. This was actually is implemented at this layer from version 2017, right? There no delay, keep alive, as you can see. But its return now is a net.server object series, right? This class is used to create a TCP or IPC server, right? A listening TCP net.servers can transfer to a worker thread by listening the transfer list of a worker threads. Post message call. This move the underlying listening socket to the receiving threads. And again, this might go beyond the scope of today's video. Transferring TCP handles to other threads. But again, this is how now all different concepts like threads comes here, and what a thread here, or what a worker thread is. Okay, so in other words, here we want to create our server, right? And it say, hey, it's create now a TCP or IPC server. Okay, so if we read about this, it say, hey, if allow half open, which is one of this properties set to true, when the other end of the socket signal the end of the transmission, the server will only send back the end of the transmission when socket.m is explicitly called. For example, in the context of TCP, when a FIN package is received, a FIN package is sent back only when the socket.n is explicitly called. Until then, the connection is half closed, non-readable, but still writable. See the end event, which is part of this, right? if you look at this real quick, it's just actually saying, hey, now how internet hosts or computers are going to implement is the communication layer here, right? So you can see here is the internet architecture, internet layer protocol, transport protocol. You know, you can get a sense of what we are doing, but at the end of the day, it's just to send message. And this particular object here, it allows you to create now a TCP or an IP server. Remember, both of them are stream-based servers to communicate with another program, whether it's locally or remotely. So this is good, right? Then the TCP can be TCP server or an IP server, depending on what it listened to, right? So here's an example of a TCP echo server which listens for connections on port 8124. And remember, it's using its TCP on this port because now the protocol actually wants to make sure that whatever data that you send here, on the other side you're gonna get in order, error-free. All right, that's interesting. So here's the thing. So this is it, right? You get this idea. Here is gonna give you now is a representation of that connection, right? And you can is end the connection here. So when starting to listen for that, client is connected, and then after that, you can end the connection here, right? And not only that, you can start to listen for any errors on the server, on the TCP or IP server, and crash the application, right? And throw some error here. And here you're saying is, hey, let me listen this application at this port, and any incoming message that I receive, right? Well, I want is to now execute this statement as it is. So this is test this by using telnet. Remember, do you remember what we look here of the application that use now is TCP as a way to communicate to other applications, to other programs like telnet and SSH, right? So we use now telnet to do so, and to listen on the socket, you can say is only like this, right? Hey, let me now listen to this socket, which is a file, right? And here is using the NC to connect to a Unix domain server. This is a good segue because what in the French toast is an NC, bro? Right? And I'll be right back. Okay, this was a real interesting segue that I took. NC is now part of the user space libraries for anything related to the network or socket connections here. So don't take my word for granted, and let's go to is look at the NC, right, from actually the Unix. And what it's doing is behind the scenes, right? So the NC or the network cat, utility is used for about anything under the sun invoking TCP or UDP. So it can open TCP connections, it can send UDP package, listen on arbitrary TCP and UDP ports, do port scanning, which can be quite illegal in some jurisdictions, and deal with both IPv4 and 6. So the thing here is that simple TCP proxies is shell script based HTTP client and server, network daemon testing, a SOCKS or HTTP proxy command for SSH, and so on. So the whole point of this is that now this is using this is at the end of the day is a tool reading is a program in C that is using the underlying kernel, Linux kernel utility functions like socket for that. So when you look at this example and say, hey, this is how you can actually make sure that you are now starting to listen for this connection, all right, to test the connection on TCP server or on UDP servers, right? So now, finally, to what I really care here is after I look at that particular example, and since because now in the realm of Node.js applications, the event-driven asynchronous architecture is one of the things that you're going to encounter in all of the or most of the core APIs in Node. So for example is an HTTP server or standard input and output. So things like the event, which is now part of the model here, all right, it's pretty simple, right? Is certain objects that they call emitters, which you now emit an event that can cause to call a function. So this is what the event is doing behind the scenes at the end of the day. So when you now use these kind of objects, so according to the doc, you say, hey, when you're creating a server, a TCP server or a UDP server, all right, when you started to reading for file in a stream, emits an event when the file is open, and when your stream emits an event wherever data is available to be read, right? So this is just describing is the common two main cases here, right? So this event emitter is just say, hey, this is the shape of this event emitter. And it takes a lot of inspiration from the DOM event model, all right? Or how do you handle with events in the browsers? And this is the anatomy of the event listener when you create that, right? So this is part of the events. This is part of the properties that you have, as well as the functionality. And most of the time you look at for this, you say, hey, how many of these incoming requests do we have, listener count, for example, on this specific event, right? The emitter of, on, once, prepend, sec max, right? This is just to notify when something happened. So, if I now finally go back to the code, which is exactly what a socket is, and well, is now I have access to this interface, which is for the event emitter, right? Where now when you JavaScript or Node.js binding detects an incoming message here, right? It's gonna give me now these things called chunk. So again, a very good segue here, because when you read more about this and you say, okay, if this is the event name, and because this event's name contains a list of events, and in that particular case is for the socket on the data, right? So this is more a general list of events, right? But now want to go is to the specific one, that is the socket. Under the net, that's right. That is under the socket, and here I'm gonna listen for that. So this is when you create a server, all right, and this is when you're starting to receive some incoming requests or some incoming message. So this class is an abstraction of the TCP socket, or a streaming IPC endpoint. Use name pipes in Windows and Unix domain sockets otherwise. It is also an event emitter, right? So a net socket can be created by the user and used directly to interact with a server. For example, this returned by the net create connection, so the user can use it to talk to the server, which is something that I'm going to explain that real quick in today's video. It can also be created by Node.js and passed to the user when a connection is received. Okay, and this is the core of all of this. For example, if it is passed to the listener of a connection event emitter on a net server, so a user can use it to interact with the client. So transferring TCP handles to other threads. This is again, maybe go beyond of the scope of today's video, but what you can do is to say, hey, when I'm starting to listen for this incoming package, I want to create, or I want to pass that to a worker or to a thread. Go beyond the scope of today's video, but this is how you can actually squeeze the power of your HTTP server by using the amount of available threads that you can create, at least in this server, and on a single connection you offload now all of this to do X, Y, and Z, right? So this is how now a net socket is. At the end of the day, you're gonna have your options, right, and the events here. So like close, connect, connections attempt, all right, connection attempt fails, connection attempt timeout, and the data. So when data is received, again the question is, who determines when the data is received? So it is not up to you. It is up to the underlying library, or it is up to the underlying API, or particularly is it is up to the OS that now is going to manage that and do all the heavy lifting. And because the OS receives now some chunks of information when something happened, that data comes as a raw byte stream. But the useful things of Node is that instead of you having to deal with that raw byte of data, so you can have, if you want the buffer, I can give it to you, right? And this buffer is now an unsigned things like this. So this is the buffer. It's a class for the buffer class is global type for dealing with binary data directly. It can be constructed in a variety of ways, right? But anytime that you want to deal with this binary data, well, you have now this temporary place that Node provide for us to this, right? You say UTF-8 and that's it, right? So this data actually comes in this binary format. Particularly this binary format is in this shape as it is, right? The size of this I think is the size of the buffer is, that's interesting. The largest size allowed for the single buffer on 32-bit architecture. This value is around 2 gigabits, all right? And on 64 architecture, this value can be up to a petabyte. Again, this is the maximum ideal value, but usually you don't have that space in memory reserved for that application. You usually have small, so you have to think about that piece of data that you want to store. But it reflects now is an unsigned integer 8-bit array, right? That's what it's doing. And when you say, hey, what the French stuff is this unsigned bit, array is come from the v8 engine, right? So the v8 engine is say, hey, this is actually what is the unsigned data, right? And to make it more explicit about that, each one of those positions, at least here, right? When you create now a buffer, and don't take my word for granted, let's go to actually see that here real quick. So when you now get into this environment, say, hey, Node, right? And I want to have access to the buffer, and I think that no. Sorry about that. Oh, we're close. Yeah, sorry about that. It's not this, not at all. There you go. This one. Okay. Yep. So again, I wanna get access to this. No, buffer. I think this is globally available, so I don't need to import anything, right? And if I say, hey, I want to create a buffer of the size of 2, right, and then and store that into array here, right? Buffer is deprecated due to security and usability issue. Please use the buffer.allocate, allocate on save, or from method instead. Okay, that's good. Okay, no problem. Say buffer dot allocate, and I want to create now is to because it's already used. You're right. So now if I want to look at what the array 1 is or contains, right, and it has this. So luckily for me, I can say, hey, on the array 1 and on the first position, I want to now is store is this number, and when I console again, it is stored in that position. So the question here is that oh, what? Really? Okay. And if I say, hey, but now this time I want to modify is the value that I want to store here. So now is this here. So what it's doing here is because instead of showing you is the decimal representation of 255 or the binary representation, which is 8 bytes or 8 digits, it's gonna show you now is a compressed version of it, where each 4 bits is gonna be used as to represent is the a hexadecimal character. This is why you can see here is this 2FFs here. So now with that, okay, I want to go out here. Fair enough. So because now this chunk can be received by the OS as raw binary of data, but the V8 engine say, hey, I'm gonna give it to you now into this specific format, the unsigned 8-bit. Yeah, the unsigned 8-bit. So you can have that in that format, or you can have it as a string. But in this case, I use that as a buffer here. And that is actually because buffer is allow me to transform that raw by string into a string by indicating that and I do some string operations here. Is just to actually here to retrieve is the things called request line. Request line is part of the things that we're gonna explain that in the HTTP 1.0, but that's the whole point of the HTTP message encoding, or the format of the message. So here is actually I get this raw byte of data, I transform that into something that I can understand as a human, like language characters, humans natural language symbols, right? And from that request, I want to get is the get, or the methods, and the path, right? And because this service is only handling is get requests, anything that is different from that, I don't know what you mean, right? And I'm gonna end the connections for that. So I'm going to indicate to the node, hey, that's going to now close the connections as it is. Remember, we are doing this is because we are using here the create server to set up a TCP server, a connection-based server. This is why we have to end the connection. And then, well, I'm going to create the body to send that piece of information. So this is my port, all right? Here now I want to start to listen for incoming message in this server, the TCP server. Here is this way of how can I create now a TCP server or a UDP or a Unix-based socket, but in this case only a TCP server. And here I just simulate now some requests, right? When this server actually runs. So here's when I actually sending is this message like this. And because part of the assumptions that the protocol says that, hey, we're assuming that we only get documents, and those documents are going to rely on the TCP connections. That's it, right? That's it. So what this raw request is something very interesting, because yeah. Okay. Is that since on Node.js application you have now the ability to use the net interface that allows you to create a client or a server. This is exactly what we do here with the client. And for the client, we need to create a connection, right? Again, this is going to use now is behind the scenes. When you look at this, right? When you look at this, let me pull real quick is the docs here, which is on the net, is this one, right? So you got this. Since this net, it's a hey, I'm gonna give it to you is the ability to create a client and a server, okay, like this. So here when you're gonna create connections, this is what I'm gonna do behind the scenes. So it's a factory function, and a factory functions is part of this design principles in computing that say anytime that you need to create something new from that, a new object, say factory functions, which is part of the design patterns, right? It is part of the creational pattern, right? The factory functions. Yeah, this particular pattern is quite interesting. they already created that. Okay. So a factory is a function whose job is to return an object, possibly different shape of objects depending on what you pass in or they parameterize, without making the caller deal with new class hierarchies or objects or knowledge of which concrete types they are getting back. So the TLDR is that this is part of the design pattern, a creational pattern. Anytime that you want to create a new object with a set of parameters, and you don't want to use the new keyword or cast the entire jungle to create that object, which is something that happened with the object-oriented programming when they rely on creating objects using this hierarchy. So in modern JavaScript, you almost never need a class to do this. A function that closes over some configurations and return an object literal is enough. The interesting questions are no longer how do I implement a factory, but when does a factory beat a class, and when does it beat a discrimination union or a dependency injection container. And this is the minimal factory function here, right? Remember that at the end of the day, this is all about is creating objects. Okay, so think about this example real quick, right? When you want to create a logger here, you're going to pass now this, which is the default values as it is, and initially, or this will be is the default value that this object will have, but initially you will have to make that as empty, and here is when your logic begins. So I want to create now an object that holds this piece of information and store that into this identifier called rank. I want to also store some piece of information, but in this case is to retrieve that information from the ranks, given the level info that I receive here, right? And then create is now a log function, where this log function, we're gonna say, hey, given this now parameters, the level, the message, so on and so forth, I'm gonna run some functions here, right? And then I'm not gonna give you anything, right? If the ranks is below to the threshold, right? But if it is, I'm going to just print the message for that. And after that, I'm gonna return now is the object, right? And in this object, as you can see, this is like a table when you have now the key and the function that is going to call another function, right? And the key and another function and so on and so forth. So two things make this work as a factory rather than just a function that returns an object. It just encapsulates the setup, so the ranks maps and the threshold look happen exactly once. When the logger is a constructor, every call to the log one reuse those capture values, and it returns an interface, not a type, right? Colors depend on the shape, debug, info, warn, and errors, whatever that came from a class or X object literally, or a proxy is invisible to them. And that's a decoupling factory was always trying to enable, is that, hey, you want to create now a new object, which is now a new interface, and this interface you can modify it, or you can parameterize to give you the proper values that you want to, right? A more useful example is an HTTP client factory, for example, like this. So suppose you have now this, right? You're going to create an API client. And this API client, at the end of the day, remember, you're going to have is certain methods in the HTTP clients, as well as a header that you want to, and an optional body if it needs to. So this particular way to encapsulate that, right, is quite useful for setting up things, you know. Hey, create the API client. You have now the base URL, the authentication if it's needed, and the fetch, which is gonna give it to you, is the fetch API for that. Part of the headers that you want to use, if you have now the content or the token, all right? This is when we're starting to construct is the request, okay? And I'm not going to run this request. I'm gonna do that only when the user needs it. But the whole point of this is when I'm going to create is the final output of this interface, the final representation of this. So here is just only using that. We're gonna pass is the methods, the headers, and the body, right? And once I do that, right, if I get an OK from the server, I'm using is now a synchronous function for this. If I am passing OK from the server, okay, so now return is that particular status, which is with the, I think this is not going to work because you at the end of the day needs to wait for that unless you want is the promise. But in any case, but this is the thing, right? If you don't respond, if the server doesn't give it to you an OK, something might happen. It might be at the application level, or perhaps at the transport layer, right? So some package or the connection with the socket this might not get open, or might not get open, or is closed by somebody, right? Or you have now a problem with the IP routing protocol. So the reach is not, so it is hard for you to reach the destination of that host. Or you don't even have access to the network as well. Or perhaps some low-level features like, hey, you don't even have your hardware plugged into the cable. Just to mention one example. Or you are not in the wireless, you're not connected to the wireless, okay? So this is it, right? And now, because it's gonna return you now is an interface for this particular interface is something that is say, hey, now I can is run of that. The other is this, lookup tables factory. The vehicle problem done right? When the factory job is pick the right implementation based on a stream tag, resist to urge to write a switch. A lookup table is shorter, easy to extend, and harder to forget to update, right? And adding a new field means adding a key to field factories. No editing the dispatch, no merge conflict on a non-switch blocks, and you can introspective the registry. Object or key field factory if you need to render a support fields type UI, right? Factory versus class versus the dependency injection, right? Factories are configurable, so it captures the configurations and environment switching, returning different shape and easy to mock. With class, they are now for long-lived object with identity, polymorphism via instance of, or hot path that benefit the shape of it. So again, that might go beyond of today's video and the scope, but I think that is quite revealing of why we have to use now a factory function, and returning now is a interface like a map, right? The class and the dependency injection container, right? Wiring graph of service where ownership and life cycles matter here, right? Decorator, metadata, machinery, runtime surprise, overkill outside large. Exactly, it's quite overkill outside large apps. A useful heuristic, if you reach for new some class from more a couple of places, you usually want a factory. If you reach for a factory from across model boundaries with cross-coding lifecycle concerns, request scope, singleton, transcending, you might want a container. And this is how you can actually do that in TypeScript, curring as a lightweight factory as well, and when not to use a factory. You only ever construct it one away. So it's preferred to use another thing, like a single tone pattern. You need instance of checks. You are tempted to return a React View component, okay? Component factory that close over re-rendering. Times usually misbehave with hooks and reactivity. Use composition or high-order components instead. And the factory is just a new X wrap. That's not an abstraction, it is noise. So, okay, this is where now people like Eric Elliott, right? JavaScript factory functions actually wrote about that. That's quite interesting and revealing, right? I don't think he actually used, this is just image for that, right? Yeah, long life to him. Absolutely, absolutely. And okay, good, right? Got it, right? So, this is what a factory is, right? It's a factory function. It's gonna give you now a new interface, all right, which create a new net socket, all right? Immediately initiate connection with a socket.connect. Then return the net socket that start the connection. So when the connection is established, a connect event will be emitted on the returning socket. So that makes sense. So hey, now there's an acknowledged connection. There's an acknowledged stage. The last parameter, connection listener, if supply, will be added as a listener for the connected event once. So possible signatures, right? You have the create connections, you pass only the options, or path for IPC connections, or for TCP connections, you're gonna pass this now the port, not the path, and the host and connection listeners. And this is pretty much what we want to do here in our case with the TCP. So hey, I want to create a connection, right? That I'm going to pass this object in the port as options. And when that happens, right? When that happens, well, I do want is to now is starting to do X, Y, and Z. So follow me along here with this example here, and this is pretty much what we did here. So on this connection, right? On these connections, and in this particular port that I'm going to receive to this host, in this case my local host, I do want to now run this, right? So when we started to create now a connection, okay, or when we send a message here, when we establish when we create is a connection, right, which immediately initiates a connection with the socket.connect, all right, and the socket.connect initiate a connection to a given socket, right? Exactly. So it wants to initiate a connections to a given socket. This is what we are going to do, right? I can say, hey, socket.write. Let me now write is some piece of information, which is my request text, all right, or any additional level. And when you listen for any incoming data, right, I want is again, because this is part of the receiving data here, and remember we are creating is a TCP connection, which it guarantee is a double, or this TCP connection is guarantee is a two-way data. Exactly, it's two-way connected communication streams. That's what these sockets allow, particularly the TCP. So I can write and read on this string of data that I'm going to send over here. So this is what it's doing, right? So this data, remember that at the end of the day, this is come from a raw bytes or as a string, and it comes from chunks, right? And what it's doing here is just to adding all of these chunks and store that into this response, right? And then once the connection ends, I want to now send just is so what is being received and what is not sent and so on and so forth, right? So I wrap all of this into a promise, and it's here that I'm saying, hey, let me now is run this server and say node under the HTTP 0.9 and the server I think is the Node.js HTTP 0.9 here, right? It throw me some errors because I need to indicate is the extension, right? It say, hey, there was an internal error. No. Oh, yes, right. Because there is no file there. So now let me load the server, and is what it is, right? So the first was a raw, so this is when we started the connection. Server raw request line get, right? And the server raw line is this, right? So the first request, which is here, so I just is send the welcome body here, or the welcome page. And in HTTP 1.1 style, which request hitting the same socket as it is. The thing here is that this actually changed a little bit because now the way how we construct this message is quite different here. Is when on the HTTP 1.0 was defined. So I'm gonna leave this as it is, and then start in the next video to create now an HTTP 1.0 and 1.9. But I do find that I create is a very well mapped way to describe at least in less than 2 hours how now is that you can create is an HTTP server 0.9 version in Node.js and all the different mechanisms involved as you build this. So I'll see you in the next video. Take care. Bye bye.